Good morning to all. Hope you all are fine. Today we are going to discuss the topic of mountains and type of mountains.
Mountains, a large natural elevation of the Earth's surface rising abruptly from the surrounding level, a large steep hill, a landmass that projects conspicuously above its surroundings and is higher than a hill, the sunset behind the mountains. Formation of mountains. Directly under the surface is the earth crust. This is a very rocky layer of the earth. This is layer made up of over 50 tectonic plates, which are large stone bases that are constantly moving. These plates move to form the mountains.
How do mountains form? We see them in just a moment of time, but they form over millions of years. Mountain belts extend for hundreds, even thousands of kilometers, and their structures penetrate deep into the earth, so their size and age make their formation difficult to understand. French geologist Jacques Malavier built sand models that mimic the formation of mountain belts and allow scientists to study this complex process.
In order for an experiment that runs for only a few minutes but represents natural phenomena that happen over many tens of millions of years, we have to choose a material whose deformation behavior does not depend on time. Sand is a very good material for simulating rock deformation. In the experiment, the different stratigraphic layers which represent the sediments and the continental crust have different mechanical properties. We mix the sand grains with a finer powder, which increases the sand's resistance to deformation. Thus, we have heterogeneous material made up of more resistant layers and less resistant layers.
Mountain belts are created when continents collide. In this experiment, we see two continents separated by an ocean. Now watch what happens as the plates converge. As one plate subducts or dives beneath the other, the ocean basin closes. The continental crust, which is lighter than oceanic crust, cannot be subducted. Instead, as the continents collide, the crust thickens and is forced up. Note how the sand is folded and faulted. We see similar structures in the rocks in mountains. One important factor not accounted for in this model is erosion. Erosion exposes the deformed rocks that were once deeply buried in the mountain belt. The green sand represents the rocks of the ocean basin. Note that it's been trapped between the two continents, marking their original boundary. These too we see in mountain belts. It's very difficult to understand the deep structure of a mountain belt by direct observation. The sand model allows us to compress time and space and simulates the internal structure of mountains.
Types of mountains. Mainly, three types of mountains are there. First, fold mountains. Second, block mountains. Third, volcanic mountains. Fold mountains. Fold mountains are formed due to the collision of two tectonic plates. Example of fold mountains are Himalayas, Andes, and Alps. Block mountains. They are created when large areas are broken and displaced vertically. Satpura and Vindhya, found in central western part of India, are an example of block mountains. Next is volcanic mountains. They are formed due to volcanic activity. Now we can watch a video.
Volcanic mountains. Volcanic mountains are built when molten lava, ash, cinder, and dust from deep inside the earth come out on the surface through cracks in the earth's crust and accumulate. A magma chamber is a reservoir of magma within the earth's crust beneath a volcano. The viscous magma traps hot gases within it, which are released suddenly during an eruption. The magma, originally oceanic crust, also contains large volumes of water, which in its gaseous state of steam increases the pressure within the vent. The release of gases and steam under high pressure increases the likelihood of a violent eruption. The opening through which lava and other materials come to the Earth's surface is called a vent. The funnel-shaped depression at the top of a vent is called a crater. The rock plug left below the crater from a previous eruption blows off violently, creating a hail of ash and rock. Violent eruptions result in the collapse of the top of the cone. Secondary or parasitic cones are formed on the sides of the volcanic mountain. The cone's steep sides are formed after the sticky acid lava pours slowly down the side of the cone and cools quickly. Each eruption first produces rock fragments, which are later covered by lava, forming alternate layers on the volcanic mountain sides. You can make your own volcano using some mud, a small plastic cylindrical container, red and yellow food coloring, liquid dishwashing soap, baking soda, and a glass of vinegar. Make a volcanic mountain out of mud. Make sure you have left the center hollow to fit your plastic container. Insert the plastic container on the hollow center of the volcano at the top. Add 2 spoonsful of baking soda. Add about a spoonful of liquid dishwashing soap. To this mixture, add 2 drops of red and yellow food coloring each. Carefully pour some vinegar into the container. Step back and watch the volcano come alive. Based on the frequency of activity, volcanoes are classified into 3 types: active, dormant, and extinct. Active volcanoes are the volcanoes that have shown signs of activity in recent times. There are around 700 active volcanoes in the world, including some that are under the sea. Dormant volcanoes are the volcanoes which have not erupted for a long time. There is always a danger that a dormant volcano may suddenly erupt. Extinct volcanoes are volcanoes that scientists believe have finally died. Gradually, the volcano is eroded, and in some places, the only evidence of a volcano is the remains of the hard plug that filled the vent of the volcano. Erupting volcanoes pose many hazards. Ash cloud is fatal to all the life forms in the surrounding areas of the volcano. It is often blown high into the atmosphere during the eruption, and then carried to a considerable distance by the wind. Pyroclastic flow, or a hot avalanche, a glowing cloud of hot ash, rocks, steam, and gases, moves at a speed of over 300 kilometers per hour. It causes havoc in the areas where it spreads. Lahar, or a mud flow, melted snow or water from the crater lake mixed with volcanic ash, follows river valleys at great speeds, causing damage to life and property along its course. Lava is usually the last element to erupt and rarely flows far away from the volcano. It is of little danger to people living in the vicinity. The soil produced as a result of the weathering of volcanic rock is very fertile. People live ever closer to volcanoes because of higher yields from the fertile soil, putting themselves at high risk.
Importance of mountains. Mountains are particularly important for their biodiversity, water, clean air, research, cultural diversity, leisure, landscape and spiritual value. Now we can move follow-up activities. First one is collect pictures of different types of mountains. Second one is prepare an assignment for a volcanic mountain with examples.